So my intention today is to get you into the universe of coatings, which is happening in parallel to what we saw, AI, new ways of manufacturing, resilient supply chains. So, yeah. So today I'll be talking to you gradually about HEF, its history as a key contributor to coatings. Then we'll gradually move toward PVD. And then we will see some of the applications with key measures where we are able to reconciliate both our KPIs that we share about cost and so on. Yeah. So here is HEF key figures today, but I really want us to focus on the start, 1953, where we started as a lab for failure analysis for failed components that we used to receive from OEMs. So what used to happen is back then we would focus to improve a component on the design or on the substrate material. But our founder came with one assessment, is if you take corrosion, seizure, fretting, pitting, wear mechanism, they all share one thing in common. They start at the surface of the component. So rather than changing the design or the substrate material, we would suggest a coating at the top of those same components. And then the same OEM asks us, but who can do it? And this is how we move to industrialization with the figures that you see today. So HEF's DNA is mostly to focus on two things. So first, customer requirement, but also environmental and social requirements that are pushed by governments today. So we are R&D driven, as I said. 48 million euros of investment, 80% goes into R&D, and the rest in new application. And with the special case of India, it's a focus both a market for us, but also for new innovations. So we saw a trend shifting from reapplications existing from Europe, and now our R&D center is more and more mobilized with new application, new innovation coming from India. So for instance, we spoke earlier about sustainability. Today in the group there are 2 green centers for recycling our nitriding salts, and the second one is in India. Part of the future investments that will happen in 2026 is we will have a prototype center in India, not only to serve India, but also to support the full Asia market. And likewise, we will have in 2026 a technical center in India, and it has carefully been chosen between all available countries. Yeah. So I'll move on. Yeah. So who is HEF and what do we specialize on? So the first one is tribology. So what is tribology? Is the study of the mechanism that happen when 2 components rub one against each other. So for instance, if you take your pen and you rub it against the table 10 times, you will see that nothing happens. But what if you do it 10,000 times? You will start seeing a scratch happening. HEF role when it comes to tribology is to suggest a coating that if customer requirement is 1 crore cycle of scratching back and forth, nothing should happen to my pen, nothing should happen to the table. But it has application mostly in ICE engine. So if you open, for instance, a magazine like OEM updates, you will see that the trend is shifting toward more electric vehicles or hydrogen-powered vehicles. So that's why we decided to also open new verticals, so one being photonics with optical components, optical coatings, and another one, hydrogen technologies. So there we have proposed coatings for hydrogen fuel cells and coatings to avoid hydrogen embrittlement. Yeah. So in terms of execution, so how are we able to move from a beautiful prototype to mass scale production? So the first one is thanks to R&D. We do literature review, and then we move to prototype that we test as close to real conditions as possible. And then one strength of the group is we make our own equipment so that we are sure to master fully the process. When we speak about automotive, reliability is key. So that's why, for instance, in Maremma Chennai, we process 1 lakh engine valves per day for 12 different OEMs, but with 0 ppm achieved over the past 2 years. So that is there, yeah. Then the families of technologies, so all are available in India because we are here for the past 40 years. So first one is liquid nitriding. Second one is physical vapor deposition, and DLC is a subfamily of this technology, and we will dive into it later. Another one is friction components as bushing pads. Yeah. Another family of technology, not yet in India, but soon to be. First one is functionalized powders. So for instance, today we have powder coating for electromagnetic shield. We also have powder coatings for electric vehicle batteries that can sustain 8 minutes of flame up to 800 degrees, so that in case of fire, the passenger is able to move out. We have femtosecond laser used for texturizing. So I don't know how many of you know kite surfing, but basically it's someone on a board and he has a sail. And today we have 2 brands of sail that send us the sail to texturize the surface so that the air has better adhesion and that person can jump higher. Just to show you the full extent of surface engineering and the wide range of applications. So this is our global footprint. So we have 100 locations globally, 100 plants. We spoke earlier about the need to have a resilient supply chain. So by 2 things, by being close to our customer, we are able to serve them better. But because we make our equipment, which is the same in each of these points that you see, in case of failure in one plant, we are also able to transfer the production to another. And what we see at the global level, we see also the same in India. So this is our footprint in India. Here. So moving now, yes, to the requirement. As I mentioned earlier, there are government-driven requirements. India, Bharat Stage 5, Stage 6, for instance. In Europe, we have Euronorm. In US, we have CAFE regulations. So we have to comply with this. Another topic is hard chrome replacement. How do we get rid of PFAS? So we have to be innovative to answer those requirements. But at the same time, we have the total cost of ownership when we take a look at our customer requirements. So now I will show you how with PVD, which is a very thin coating that is at the surface of the component, that is no more than 3 micron, how we can make the difference. Yes. Yeah, so what is PVD, or plasma-assisted chemical vapor deposition? Basically, I take my component, I put it in a chamber, and suppose I want to make like titanium nitride coating. I will remove all the air from that chamber, and I will create a vapor of titan, and I will inject some nitrogen in that to get the right composition that I am looking for. Yes. So this is just an example of one of our equipment. So like this, we have today 12 in India. Yes. And this is about the range of applications. So when you think about DLC, you have to think hard, and I will show shortly after why. But you can also find a wide range of applications in engine components, but also for aesthetic look, also for dyes, for instance, to extend the life cycle of the dyes, for medical applications. So another interesting medical application is the heart transplant. So 𝗙𝗂𝘁𝗄 did the full tribological study for the heart Carmack, which is today beating in the heart of 100% worldwide. Yeah. Then one other question, who is here knowing how DLC was invented or discovered? Okay, it's very interesting. So actually DLC was found out while people were trying to create fake or artificial diamonds. So they knew that the carbon configuration that you see up there when you think of diamond is sp3, meaning that the carbon has 3 links from the next one and so on. So it creates an element that has a very high hardness of 8,000 HV. But somehow they found something that has lesser hardness. So they looked into the chemical composition and the structure, and they found that there is graphite. So graphite, when you have paper pen, that's what you write with. And it's known as a solid lubricant. So today there is not one type of DLC. There are as many DLC as you can travel across this triangle. And how do I decide, do I want more hardness or more graphite? It's based on the properties I'm looking for. Am I looking for mechanical resistance? Am I looking for wear resistance? And so on. Yeah. So one first application I wanted to speak about is gears. So gears is this component. There are many types of gears, and they, it's components that mostly are there to translate torque from one component to the next one. And there you have normal load applied, but also the higher your friction gets, the more shear forces you are getting on these components. So yeah, and when you move, for instance, from a nice engine to an electric vehicle, what you notice is you get more thrust. You feel it as a passenger. But who else is feeling it? The components as well. So they need to be protected, or the design needs to be addressed differently. So as I was telling, so the gear teeth mostly, they are the ones that are suffering more from these additional stresses, whether they are normal force or shear forces. And so what DLC will bring in those specific situations is we will reduce the friction so that there is less shear force, and we will increase the mechanical resistance just with the 3-micron coatings so that the components maintain its integrity while operating. So how we are able to achieve this is thanks to having many, many bench tests. So closer to my side, you see 10 bench tests which are very far away from the engine design. It will be like plan on plan or cylinder on plan, just to test the coating first. And then if I want to test the gear, I have different bench tests where I can feed these and see how it behaves. And about results, so for this specific design, we were able to reduce the power dissipated by 2 kilowatts. So 2 kilowatts is the equivalent of 20 light bulbs. So that's how much you can think of in terms of fuel reduction. That's how much you can think of about engine efficiency, because this power hasn't been lost here. So initially, those requirements were driven by Formula One cars, but gradually, because the same requirement have come up in passenger cars, we are able to translate these from Formula One into passenger vehicles. Another application is tappet on diesel engine. So the tappets is a component, whether you have a V6, V8, V12 engine, you can have 24 of these in an engine. And here, after only 1,000 hours of operating, you can see that visually, a component which is uncoated is much different from a component which is coated. And because of this coating, we are able to maintain a low friction, a coefficient of friction. And how does it translate? It's 1.2 grams of CO2 reduction per kilometer. To give you a perspective, when we speak about barrage stage 4, for instance, like for a B model vehicle, B segment vehicle, we are thinking about 120 grams per kilometer. So 1.2 is highly significant, both for the OEM, because you have like less maintenance operations to commit for, but also for the owner of the vehicle, because you will spend less fuel per kilometer driven. And it's not only that, there is a full range of applications. There are like 30 which have been identified. We also have some for electric vehicle, differential pin, for hydrogen-powered vehicle with the Volve train. But the best is yet to come. And my message today was to convey that HEF is fully committed to answer India requirements, which are much, much different and innovative than the one that we see in Europe. We are no longer in a stage where we see re-applications in India. We rather see new applications in India that are later on transferred to US, to Europe. So if you want to take a photo of this slide also, this is how we can pursue the discussion together, either here or later on. So all these persons, including me, are based in India. So please feel free to reach out to us. Thank you very much.